to anywhere where the value is actually less than 2 but greater than 0. All right, so that's one way that you can actually do the whole thing. Or you can actually group the points. Now you can actually group the points, delete the points out, just group them, group the points. Like you can add point to group, and which is the point. Okay, I'll just disconnect this, and I'll get all the point numbers from right here. So point number. So if the point number is actually in between that range, you can actually go ahead and put it inside a group. Now we got a group as of right now which has 113 points, which actually is that particular group right there. So now if you go back up, you can actually use a delete sub if you wanted to, if that was the kind of thing you were looking for, and actually have this group called group 1, which is points in our case. And now you can actually just delete it, and under the VOPs you got this parameter which actually can increase the radius. And now if you remember, we actually set a default for this particular constant over here. I actually dropped the value a little bit, so that way it falls into a range that's actually closer to each other. So now in our case, if I increase this, I'm increasing both of them at the same time, so you actually get this hole in between, so to speak. Now that's the same thing we're going to be trying to achieve. Now there's more you can do to that, but honestly that's not even part of the whole tutorial, but it kind of serves to learning VOPs. So I'm gonna just push that up. Hopefully I'm not clustering the whole thing, but it actually, that's what I seem to be doing. Now I'm gonna put that up, and what we're gonna go ahead and do is actually focus on this. Actually, I might just go ahead and delete these guys because it's clustering the whole thing. What we're gonna go ahead and do is actually under the utility drop in a fit range right here. And what the fit range does is fit everything from default value to a new minimum, new maximum that's actually defined. So in our case, when I get the default value as this right here, and disconnect that, so I'm gonna get the length values. What am I doing? My goodness. Disconnect that, and it seems like I disconnected the thing over there, so my bad. So we're gonna be getting the default values from the length. So the length is already defined as it is, all the lengths are defined, but what we want to do is actually redefine them to a new normalized position. So in our case, we'll get the length as the input value which we want to get. So it's gonna input the value. Now you want to give it an all minimum and an all maximum. So in our case, we want to give it an all minimum of the parameter. So we want to give it a all minimum. So this being 0, that assuming it's 0, let me just put it down to 0. This is gonna be an all maximum, so it's 0 in our case for right now. And then this right here is our maximum, which is in our case actually 0.9, which is actually added to this. So if it was 1, don't forget that would be 1.9. So actually it's always higher than this one by a little bit. So that'll be our all maximum. So what we just did is actually output a portion of just this grid. Now you can actually visualize this in a few ways. Now it's in a 0 to 1 range. Now the best way to visualize the data in a 0 to 1 range is using a ramp parameter. Now this only outputs data if it's 0 to 1 range only, and that's the only way you can actually visualize the data using this. Now you can actually output this as a color. So I'm gonna just go ahead and plug in that right here under the color. Alright, and now if I actually go back up and paint this something like red, and this one to something like blue. Now if I actually go back to my VOP, or I'm on my VOP, you can actually see how the data gets visualized. You can actually visualize it like so. Actually make it yellow or something like that, probably be much brighter. Yep, something like that. So you can actually see how it actually interpolates all the data in between. Now that's all nice and dandy, but actually that's not what we're really trying to get to as of right now. The main thing for this actually was to use this as a way to ripple our grid, so that way it actually goes up or down. Now this is a ramp type of color ramp. We can actually change it to a spline ramp, and what that does is actually output, well, we don't need to output it over there, but what we can actually do is actually output this to the Y component of the grid. Now the X and Z remain the same, but the Y remains changes with this particular value. So what we're gonna go ahead and do is actually drop in a vector to float. Now all this does is just split up the components of the vector point position to X, Y, and Z respectively. So to bring, okay, now don't forget the X and Z has to remain the same, but the Y can actually change. So what you're gonna have to do is actually put this back up the same way you brought it in. So float to vector in our case, because you're flipping it back up, and X and Z remain the same because that's the same positions for the grid, but the Y actually as of right now is actually 0. If you actually even look at the spreadsheet for the grid as of right now, everything is 0 for the Y. So it doesn't really change whether you put the values over here or not. It doesn't really matter. So whether you put the values, you know, in between right here, it really doesn't matter. If you plug it in like so, it really doesn't matter because it's still the same 0. So now what you can actually do, because this is VOPs and you're here to manipulate the data, is actually use this as the Y value. So you can actually plug this in right here. Alright, so that way if I actually plug this in right here to the point position and I go back up, now everything is just 0 as of right now. So actually if I click on the middle and kind of lift this up a little bit, if you're looking at the viewport, you can actually see that you actually manipulate, you know, this grid as so. Now don't forget, even though I actually won't be dealing with this, if you actually do an anti-alias noise, which gets the vectors for this from the points over here, if I can actually click it and bring that out, it's gonna output a noise value, which actually you can add up to this and output this. Let's see whether that works. Actually, I'm not even supposed to try that out right here. Well, I guess it won't work as so, but again, I tried. And so this is actually how you actually do it correctly. So you take the float parameter, make a float vector, make a vector out of it. So plug in all the 3 components to the X, Y, and Z from the ramp parameter, and make that a vector and plug that into the noise, and whatever noise values you get, output that, and now you can actually add that up to the original parameter attributes over here. And then after that, all you gotta do is just, you know, plug it back up, and if you actually visualize it, it just creates the same thing with a little bit more noise in it, and that's how you actually work with the thing. So let's get back to business. Okay, so forget about that. Now we're gonna go back up over here, and for one, we're gonna actually increase this add constant, so that way it actually kind of transitions a little bit smoothly, so kind of a bigger ripple, so to speak. And now if you go back up, you can actually scale this down a little bit. So now don't forget, this is Houdini, so everything is procedural. Now your boxes are actually getting the same positions from the grid. Now you can actually just kind of like scale it up, scale it down, but the boxes are really rotating or nothing, they're just in the same positions, you know, just also. I know it doesn't make any difference as much, but you know, it's right there. You can see the ripple effect. Now what we need to actually do is actually work on the rotations for this particular thing. Now we're gonna use the same feet range to actually make this work. Now if you remember from what we discussed earlier, it fits everything from a 0 to 1 range, right? So now we're gonna use another fit range, which is actually still on our history, and we're gonna get the length of the curve of the distances, and we're gonna get the old minimum as a parameter and the new old maximum as the add constant, right? Then for the, as far as for the, oops, I unplugged that. Okay, as far as for the new minimum and new maximum, we're gonna leave it at 0. Then for the new maximum, we're gonna change it to 180. Now what 180 means is a full 180 spin on the same axis for us in our case. So now we're gonna be split from the time it begins from 0. It's gonna begin at 0, so 0 is 0, and by the time it gets to the particular value that it is, it'll actually flip. We'll give this a rotation value basically eventually, so it's going to be rotating 180 degrees by the time it gets to a value of 2.4. so we're going to be remapping pretty much, if you want to think of it like that. So 0 is 0, 2.4 is actually 180, or you can actually have it as 2, whichever one you want. But you know, don't forget that's actually what's making this ripple kind of broaden out, kind of smooth or sharp or whatever that you want to do to it. So now easiest way to get the data out of VOPs is actually go ahead and under geometry add an attribute, and just gonna plug in the data out of there, and this attribute is gonna be called rotate. Alright, so now we got a new attribute called rotate right here. So it's a point attribute called rotate, and actually you can now use that in the VOP level to SOP level to actually manipulate the rotations. Now we have two problems as of right now. Well, one problem, but which is solvable in two ways. Now we're gonna create an attribute over here called, well, a token over here called rotate, right? Now over here I have a variable of a point attribute called rotate, but it has no variable mapping to it, so it's not really defined. Literally, it's not actually defined in Houdini. If you remember, usually if you have something created in Houdini, it has this small letters, then uppercase name for the same variable. So in our case, what we're gonna go ahead and do is actually, for one, you can actually use the point expression to get the data out. So in our case, you can actually use point